Question number one. To apply integration by parts, we just need to figure out what the parts are. So here the parts are given. So the way we normally choose the parts is we choose the dv part as the most complicated part of the expression that we can integrate, that we are able to integrate. So in this case here, our choices of parts are x and sine x, for example 1. And the sine x is a more complex function. So we're going to choose that as our dv function. So we've got our dv in red here. And we're going to then let u be the x function. So once we have u and dv, we need to generate our other parts. We need to generate our du. The du we find from u by differentiating. So here we get du is equal to 1, and then we're going to put the dx on that side. The dv, we find the v part, and we find the v part by integrating sine x. So the v part I'm going to end up with the derivative of negative cos is sine, so that's my v. V is negative cos x. So once I have those parts, I just apply the formula. And hopefully what I get in the new formula is an integral that can be integrated. So here, x sine x cannot be integrated. So hopefully when I do a rearrangement, I'm going to end up with an integral that I can integrate. So I'm going to start with u. So I'm going to end up with uv. So v is negative cos x minus the integral of, this is the integral that I want now. It's going to be negative cos x, and then the du is going to be replaced with a dx. So this is what I then look for. I look at the new integral and I ask myself, is this easier to work with than the original integral of sine x, x sine x? And clearly is, because we know the antiderivative of cos. So then I can go ahead and anti-differentiate that part. So I'm just going to make sure I clear up my signs here. So this is negative x cos x. This is going to be plus. The antiderivative of cos is going to be sine. So I end up with sine x. And then there's my plus c. The plus c, I need to make sure I remember. So there it is. So the integration by parts, what it does is it generates a new integral. And hopefully that new integral is easier to work with than the original integral. So the integration by parts formula is just a rearrangement of the original formula, of the original question. Now I can always check my integral by differentiating. So this is my check then. So if I differentiate the answer, I'm going to end up with 1 times cos x plus x times the derivative of cos is sine, so negative sine, plus, that's going to give me the derivative of sine is going to be cos, and then the derivative of c is 0. So when I work out the signs here, I'm going to end up with negative cos x, and so I'm going to end up with negative cos x plus cos x is going to cancel out. And then I end up with x sine x. This should have been a plus. X sine x. So there it is. So when I check it, it works out.